I found that many people believe that after a carrier-based aircraft is catapulted from the aircraft carrier, the pilot pulls the stick back to lift the aircraft up. But in fact, this is a serious misconception. If you have looked at various materials, you may find that in reality, the pilot's hands do not touch the control stick at all during catapult launch. So in this video, I will use the standard catapult launch procedure to give you a more intuitive understanding of the various operational details when a carrier-based aircraft leaves the ship. Next, we will talk while flying. In reality, there are 3 procedures for carrier-based aircraft departing from the carrier: Case 1 departure, Case 2 departure, and Case 3 departure. The biggest difference between them is daytime or nighttime and different weather visibility, so the aircraft will choose different departure procedures. Currently, in our simulation environment, the weather is good and visibility is high, so we will also perform a standard Case 1 departure. Next, we enter the cockpit. To save video time, I have already started the aircraft by default, but starting it does not mean the aircraft can be directly catapulted for takeoff. We still need to perform important checks on the aircraft first, such as the aircraft takeoff trim that many people do not know or overlook. Because carrier-based aircraft carry different weapons each time they go out for combat or training, the takeoff weight of the aircraft will also be different. So if the aircraft is not trimmed before catapult launch, under heavy conditions the aircraft may fall into the sea right after being catapulted. Therefore, trim is a very important procedure before catapult launch. For example, currently our aircraft's total weight is about 45,000 pounds. Then, according to the requirements in the manual, trim the horizontal stabilizer to 17 degrees. Toggle the trim button on the control stick downward to 17 degrees. Okay, this way after catapult launch we do not need to pull the stick immediately, and the aircraft can automatically establish a positive rate of climb. Next, because we are going to execute the standard Case 1 departure procedure, we need to first input the carrier's TACAN into the aircraft. TACAN is to make it convenient for the aircraft to obtain the carrier's bearing and distance in real time. If TACAN is not input, then after the aircraft takes off it cannot accurately determine the position of the carrier. Click TACAN, input the carrier's TACAN, then select TACAN. Next we set up a course, which is the carrier's BRC. BRC is the carrier's base recovery course. Here the carrier's BRC is 0-20 degrees. Adjust the aircraft's course control switch to 0-20 degrees, then a line will appear on the instruments. This is the carrier's direction of travel and also our flight direction after leaving the ship. Up to this point, we have completed the instrument settings before catapult launch. Next, the pilot can salute the yellow jersey deck director to confirm readiness. In reality, there is also another step. The carrier strictly controls lighting. Unless the carrier-based aircraft is preparing for catapult launch, at all other times no aircraft is allowed to turn on any external lights. After we have completed all checks, we can request to taxi. Release the parking brake and slowly advance the throttle to make the aircraft start taxiing. The entire taxi process is relatively simple. Just follow the director's instructions and taxi to the corresponding catapult position. During the taxi process, we can first simply understand the Case 1 departure route. There are 4 catapults on the carrier, corresponding to 4 catapult positions. Aircraft taking off from catapult positions 1 and 2 must first turn right to clear after being catapulted, while aircraft from positions 3 and 4 must turn left to clear after catapult. This turn is called a clearing turn. Why does the aircraft perform a clearing turn instead of flying straight out after being catapulted? Because the clearing turn is not only to separate departing aircraft left and right to prevent collisions, but more importantly to avoid the waterway directly in front of the carrier. If the aircraft has an accident and unfortunately crashes into the sea, the clearing turn can also ensure that personnel and wreckage fall outside the carrier's track and will not be secondarily crushed by the following carrier hull. Okay, hand it over to the next director. Currently, this director's hand signal is telling us to unfold the carrier aircraft's folded wings. Operate the wing fold control handle clockwise and slowly align with the carrier's catapult track. The Hornet's nose has 5 antennas. The middle one can more easily help you find the centerline position. As we get closer and closer to the catapult position, The director signals us to stop moving forward, then apply brakes and stop the aircraft at the designated position. At this time, the green-jerseyed catapult officer will walk to the side of the aircraft's nose landing gear, check and connect the catapult system. Now we lower the carrier aircraft's launch bar. The launch bar is located on the nose landing gear of the carrier aircraft and is used to connect with the carrier's shuttle. At the same time, another green-jerseyed holdback bar operator is responsible for connecting the holdback bar. The holdback bar is about 90 centimeters long. One end is fixed to the deck fixed seat behind the catapult shuttle, and the other end is attached to the aircraft's nose landing gear. The function of the holdback bar is to firmly lock the aircraft. Even if the pilot advances to full afterburner, as long as the carrier's catapult does not apply force synchronously, the aircraft will not surge forward. Now the director's hand signal to us is to slowly taxi forward so that the launch bar goes over the shuttle. Then the shuttle will slowly move forward, making the entire airframe tensioned and enter the pretension state. At this time the airframe is taut. The pilot can release the brakes and retract the launch bar. The aircraft has already been firmly fixed by bidirectional tension, and the catapult is also ready and standing by. After confirming no errors, at this time everyone will be watching our aircraft. After the catapult officer gives the signal to increase thrust, we push the throttle to full, check that the engine RPM is normal, then move the control stick left, right, and forward aft to check the flight control surfaces, ensuring every control surface is normal. After confirming everything is ready, the left hand grips the throttle against the stop, and the head presses firmly back against the headrest. To avoid pilot-induced oscillation with the flight control system, during the catapult process, the pilot must not move the control stick. Place the right hand on the aircraft's handhold. Throughout the catapult process, the hand does not touch the control stick at all. Then we salute the catapult officer and at the same time turn on the aircraft's external lights. After the aircraft is catapulted out, retract the gear and flaps. Then bank 20 degrees to the right to perform the clearing turn. During the entire Case 1 departure process, the aircraft speed is usually 300 knots and altitude 500 feet. The HUD has a bank angle indicator. Each large mark represents 15 degrees, and each small mark represents 5 degrees. When we maintain a 20-degree right bank and reach the carrier BRC plus 20 degrees, that is heading 040, we can turn back. At this time, bank 20 degrees to the left again and fly back to the carrier's BRC, which is heading 020. Just now we took off from catapult position 1, so we turned right. If we take off from catapult position 3 or 4, then we need to turn left. The steps are the same. Bank 20 degrees and turn the heading 20 degrees. Now we have reached heading 020. Next, we only need to fly straight. Maintain speed 300 knots and altitude 500 feet, and fly straight until 7 nautical miles from the carrier taken. Then we can leave the carrier's control area and request to depart. From the HSI, we can see that now we are parallel with the carrier's heading. So this is the complete standard Case 1 departure process for the Hornet fighter. This video can be said to have solved many people's detailed teaching on carrier-based aircraft being catapulted from the carrier and then climbing. Of course, there is also Case 3 night departure. Another day, I will make an episode about the Case 3 departure process. So today's video ends here. See you in the next video. Bye-bye.